Hello everyone, welcome to the Click Physics 1 course. Today we're going to discuss vectors and resultant of vectors. By the end of this lesson, you will be able to define the resultant vector, explain the geometric methods, distinguish between the methods, calculate the magnitude of a resultant vector using algebraic formulas, and solve problems involving vectors at different angles. Well, before we begin our lesson, here we have a diagram for types of vectors. We had already discussed them in the previous lesson, but in here it is better to understand the 6 common vectors with diagrams. Okay, so what is a resultant vector? The sum of 2 or more vectors is called a resultant vector, which in simple terms we can say that it is a single force that represents the combined effects of all forces acting on an object, and it has both magnitude and direction. And there are 2 main ways or methods for finding the resultant. First is the geometric method, and then the second one is algebraic method. The symbol that we use for representing the resultant is R, written in capital. The geometric method has 2 methods for itself. The first one is called the parallelogram method. Well, when 2 forces act from the same point, you draw them as the 2 sides of a parallelogram. The diagonal line from the starting point represents the resultant force. So the steps for this method is that we first move the vectors so that they have the same starting point or common origin. And then from the end of each vector, we draw a line parallel to the other vector. And this creates a parallelogram shape. And then the diagonal of this parallelogram that starts from the common origin represents the resultant vector. And this method is mainly used when we are adding 2 vectors together. The second method is called the polygon method, which is also called the triangle method. And it is when 2 vectors are placed head to tail, which means the end of the first vector is connected to the start of the second. And as you can see it here in the diagram, the head of the F1, which is force 1, is connected to the tail of F2. And the line joining at the start of the first vector to the end of the second vector represents the resultant vector, which is shown here by the letter F. And in simple terms, putting vectors one after another, the arrow from the beginning to the end is the result. Factors affecting the resultant. The magnitude of the resultant vector depends on 2 main factors. The first factor is the length of the vectors. Larger vectors usually produce a larger resultant. The second factor is the angle between the vectors. When the angle between 2 vectors becomes smaller, the resultant becomes larger because the vectors act more in the same direction. However, when the angle becomes larger, the resultant decreases. And for example, the maximum resultant occurs when the vectors are in the same direction with an angle of 0 degrees. Now we move on to the algebraic method. Instead of drawing vectors, we can calculate the magnitude of the resultant using a formula. For 2 vectors with magnitudes a and b and an angle theta between them, the resultant is r equals the square root of squared plus b squared plus 2ab cosine theta. This formula is based on the cosine rule from geometry. And here r represents the resultant vector, a and b represents the magnitudes of the 2 vectors, and theta represents the angle between them. Here we have some shortcut formulas because the original formula may be hard to use every time for using a formula. Like, why not use the shortcut formulas? So for some specific angles, this formula becomes simpler. First, when the vectors are parallel and in the same direction, the angle is 0 degrees. Cosine 0 degrees equals 1, so the formula becomes r equals a plus b. This is very simple, yeah? Well, the resultant is simply the sum of the 2 vectors. Second, when the vectors are perpendicular, the angle is 90 degrees. And cosine 90 degrees equals 0, so the formula becomes r equals the square root of a squared plus b squared. And this is the Pythagorean theorem. Okay, so third, when the vectors are parallel but opposite in direction, the angle is 180 degrees. The resultant becomes r equals the absolute value of a minus b. So let's look at some examples. In the first example, two vectors have lengths of 30 centimeters and 18 centimeters, and they are in the same direction. Because the angle is 0 degrees in here, we use the formula r equals a plus b. So r equals 30 plus 18 in here, which gives us r equals 48 centimeters. For the second example, two vectors of 8 centimeters and 6 centimeters are perpendicular. So for this, a equals 8 centimeter and b equals 6 centimeters. So for this problem, we use the second formula, which is r equals the square root of a squared plus b squared. So r equals the square root of 8 squared plus 6 squared. And this gives us r equals 10 centimeters. Okay, so for problem 3, two vectors of 5 centimeters and 8 centimeters with an angle of 60 degrees. We are given A, which equals to 5 centimeters in here. B is 8 centimeters, and the theta sign for us in here is 60 degrees. And we must find the resultant here. So the formula we use for this problem is the resultant vector formula, It is r equal to square root of a squared plus b squared plus 2ab times cosine of theta. It is the theta given is 60 degrees, and in here we must find the cosine of theta too. And we substitute the values first, which is r equals to square root of 5 squared plus 8 squared plus 2 a and b. We put the values for those, which is 2 times 5 times 8 and times cosine of 60 degrees. Okay, since the cosine for 60 degrees is equal to 1.5, then in here we would put 1.5 instead of cosine of 60 degrees, okay? And in here, if we put this 1.5 in here, okay? Either way is correct. So moving on with the problem, r equals 25 plus 8 squared is 64 plus 2 times 5 is 10, and 10 times 8 is 80, and then times 1.5, it gets half, so it will be 40 in here. Then adding all of these up together, we get 25, get 55, 65, and then we have 120. And here we are done. Thank you for watching.